Hello friends, Mr. Burrell here. We're in a new unit. We just finished talking about probability. Now we're going into talking about circles. There are just a couple lessons we're going to have associated with circles, and therefore just a couple of quizzes that we'll have. This is going to be a pretty short unit that we'll finish up really quickly here towards the end of the trimester. So to get started with circles, here is what we're going to start with. We're going to start talking about circumference and arc length. So hopefully circumference is something that you've already been exposed to, that you kind of already know how to find. We're going to review that, and then we're going to take that into arc length. We're going to talk about what an arc is and how we can find an arc's length. So by the end of this video, by the end of this lesson, this is what I hope that you are able to do. I hope that you're able to find the circumference of a circle given the radius or the diameter. We'll talk about those terms if you don't remember what they mean. And then also, I want you to be able to find an arc length given the angle in degrees and the radius. So we'll talk about, again, what an arc length is, how to determine an arc length using the angle in degrees and the radius. So, as a reminder, again, hopefully this isn't terribly new information, but the circumference of a circle is the distance around the outside of the circle. So this distance right here, usually when we talk about the distance around a certain shape, we're talking about the perimeter. In a circle, we usually call it the circumference, the distance all the way around the outside of the circle. And the circumference of a circle is given by this formula. Circumference equals 2 pi r, where r is the radius, which is the distance from the center of the circle to the outside of the circle. So the distance from the center of the circle to a point on the outside of the circle, that distance is the radius. Note also, if you remember, that the diameter is twice the radius. So the diameter is the distance from one point of the circle to another point on the circle going through the center of the circle. Therefore, the diameter is 2 radiuses, or double the radius. Okay. So, here's some problems. Again, if you have printed off the guided notes for this unit, you can follow along in those guided notes or just follow along on your own notes, whatever you feel to do. But these questions say, find the circumference of each circle with the given radius or diameter. Round to the nearest tenth. Use 3.14 for pi. So pi is an irrational number, right? 3.1415926, etc., 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 etc. You don't need to type in all those digits. It'll be good enough to use 3.14 for pi. So let's remind ourselves what the formula for the circumference of a circle is. Circumference is equal to 2 times pi times r. 2 times pi times the radius. So this circle has a radius of 6 centimeters, which means the circumference is going to be 2 times pi times 6, or 2 times 3.14 times 6. So I'm going to go ahead and just type that in my calculator. 2 times 3.14 times 6 is 37.68. So the circumference of that circle is 37.68 centimeters. And it said round to the nearest tenth, so we'll round that to 37.7 centimeters. Okay, so on this one it says the diameter is 47 feet. Well, my formula calls for the radius, not the diameter. But I know that the radius is half of the diameter. So the radius is just half of 47, or 47 divided by 2, which is 23.5. So the circumference of this circle is 2 times pi, or 3.14, times the radius, or 23.5. 2 times 3.14 times 23.5 is 147.6 feet, since that was given to me in feet. So the circumference of that circle is 147.6 feet. This last one says a pop can has a radius of 1.5 inches. So imagine the top of my pop can here with my little, this thing that opens it up, right? Maybe there's a Mountain Dew. I don't know. So the radius of my pop can is 1.5 inches, so the circumference is 2 times 3.14 times 1.5. 2 times 3.14 times 1.5 is 9.4 inches. The circumference of that pop can, the distance around the outside of the pop can, is 9.4 inches. Okay, now I want to give you a problem like this. This problem says find the radius with the given circumferences. So remember, circumference is equal to 2 pi r, 2 times pi times r. So what if I was given the circumference and I want to find the radius? Well, let's try it out. Circumference is equal to 2 times, the circumference was given to us, being 43 feet here, is equal to 2 times pi times r. Well, I need to solve for r. This just becomes an equation. So I need to solve for r. R is being multiplied by 3.14 and multiplied by 2. So I'm going to divide by 2. 43 divided by 2 is 21.5. So 21.5 equals 3.14 times r. And then I need to divide by 3.14. 21.5 divided by 3.14 is 6.85. So my radius here is 6.85. So again, using the formula that I have for the circumference, if I know the circumference, then I can find what the radius is by just solving for r. Dividing by 2 and dividing by pi. You could also, if you want to think about it, you could rewrite this equation as c divided by 2 pi. R equals c divided by 2 pi when I divide by 2 pi on both sides. Either way, I'll leave this one to do by yourself. I'm going to go ahead and move on, but that's how we find the circumference given a radius or a diameter. And this right here is how we find a radius if we are given the circumference. And again, hopefully that wasn't terribly new information. Hopefully you've kind of been exposed to circumferences before. If not, that was a brief review. Now we're going to start talking about arc length. So let me move my face out of the way again here. What is an arc? Well, an arc on a circle is the distance around the outside of the circle connecting two different radii. That reads radii, that's just two different radiuses. So like on this circle right here, I have a radius here, I have a radius here, and the arc on that circle is the distance around the circle connecting those two radiuses. So it's just a section of the circumference. The circumference would be all the way around the circle. An arc is just a section of the circumference that connects two radiuses. And those radiuses are separated by a specific angle measure here. If you remember, the distance all the way around the inside of a circle is 360 degrees, right? The distance all the way around the inside of the circle, all the way around in the circle, is 360 degrees. So an arc length separated by two radiuses is going to have some angle in between those two radiuses between 0 and 360 degrees. Just a section of the inside of the circle, a section of that 360 degrees corresponding with a section of the circumference, which we call the arc. Okay, so this is the formula to find the arc length. Length is equal to n degrees divided by 360. So n degrees is the angle between the two radiuses. So I take that angle divided by 360 because I just want the fraction of the circle that is between those two radiuses, times by 2 pi r, or in other words, times by the circumference. Again, it's just a fraction of the circumference. The same fraction of the circumference as corresponds with the fraction of the degrees on the inside of the circle. So here it says, notice that to find the arc length, you multiply the circumference of the circle by the fraction of the circle that that length takes up. So let's do an example. This one says, say r is equal to 7 and n is equal to 80 degrees. So let's say the radius here is 7 and this angle here, n, is 80 degrees. Well, to find arc length, I take n over 360 times 2 pi r. So I'll take 80 divided by 360, because that'll give me the fraction of the circle that that arc length takes up, 80 divided by 360, times by 2 pi, which is 3.14, times r, which is 7. So I can just do that on my calculator. Let's see, 80 divided by 360 is 0.222 times 2 times 3.14 times 7, and that you can just type straight into your calculator. 0.222 times 2 times 3.14, it's supposed to be a 1, times 7. And I get 9.76-ish. 9.76 is my arc length, or just the fraction of the outside of the circle between these two radiuses. 9.76. Okay, let's do some more examples. So this says find the following arc length. So here, this is number 6 on your guided notes. I have a radius of 9 and an angle in between these two radiuses of 60 degrees. So notice 60, to find the arc length, I'm going to take, I'll write the full arc length formula up here again. N divided by 360 multiplied by 2 pi r, multiplied by the radius. So 60 divided by 360, 60 degrees is that intercepted angle divided by 360, times by 2 times 3.14 times r, which is 9. That's a formula for the arc length. So 60 divided by 360 is 0.167, or 1/6. I'm taking up 1/6 of the outside of this circle, times by 2 times 3.14 times 9. So we'll go ahead and type that in my calculator. 0.167 times 2 times 3.14 times 9. That gives me 9.44. 9.44 is the distance around the outside of that circle. And just for kicks and giggles, I'm going to go ahead and compute just the circumference of this circle. The circumference is 2 times 3.14 times 9. 2 times 3.14 times 9 is 56.52. Whoops, that was good. 56.52. So that's the distance around the whole circle. So I'm going to go ahead, just for fun, we're experimenting, 9.44. I'm going to take 9.44, which was the arc length, divided by 56.52. 9.44 divided by 56.52 is 0.167. So 60 degrees was 1/6 of the inside of the circle, because 60 degrees is 1/6 of 360 degrees, or 0.167. And then the arc length of 9.44 is 1/6, or 0.167 of the circumference. So that's why this is the formula we use for arc length, because we're taking the fraction, the same fraction this is associated with the angle compared to the inside of the circle. That same fraction applies to the arc length compared to the whole circumference of the circle. Okay, here we have an angle of 90 degrees intercepting these two radiuses to form this arc on the outside here. So that arc length is 90 divided by 360, so the angle divided by 360, times by 2, times by pi, times by the radius, or 5. So 90 divided by 360, that ends up being 0.25 times 2 times 3.14 times 5. So again, I can just type that straight into my calculator, whether you're using Desmos, a fancy calculator, your phone, it'll work, whatever. 0.25 times 2 times 3.14 times 5 is 7.85 feet, or 7.9 feet. Gave us kind of a little multiple choice option here, so I know that the arc length is 7.9 feet. Okay, good. So next we're going to look at some more interesting problems, kind of some application type style problems. So this problem says, consider a standard 12-hour clock like the one below with a radius of 3 inches. So let's say I have a little clock in your bathroom, and the radius of that clock is 3 inches. Okay? And then for these problems, we're going to use the shortest path between the two numbers. So, it says, what is the length of the arc between the 3 and the 8? So I'm going to go ahead and draw I'm going to write the radius is 3 inches. I'm going to draw a radius to the 8 mark on my clock and the radius to the 3 mark on my clock. So the shortest path between those two numbers, I want to know this arc length right here. Okay, Well, what do? It doesn't give me an angle measure, but what I do know is all the way around this whole circle is 360 degrees. And notice that a clock face is split into 12 equal little slices here, right? 12 slices. So, what fraction of the inside of this circle is being taken up by this arc? Well, I'm taking up 1, 2, 3, 4, 5 little slices. 1, 2, 3, 4, 5. 5 out of the 12 slices. So the fraction of the circumference that I need to find is 5/12. Another way that you can think about this, if you wanted to calculate what this actual angle is, 360 degrees divided by 12, let's do that real quick. 360 degrees divided by 12 is 30 degrees. So each one of these little slices right here is 30 degrees. So then 1, 2, 3, 4, 5 of those slices would be 5 times 30, which is 150 degrees. So my arc length would be 150 divided by 360 times by 2 pi r, or the radius, which is 3. But notice, if I take 150 divided by 360 in my calculator, I get 0.417 times 2 times 3.14 times 3. But notice also, right here, 5 divided by 12, when I just did this fraction right here, 5 divided by 12 is also 0.417. So again, when I'm finding the arc length of a given section around a circle, I'm just taking the fraction of the circumference. I'm just taking a fraction of the circumference. In this case, the fraction of the circumference was 1, 2, 3, 4, 5 out of 12 total sections around the circle. So that's what I'm going to use for the rest of these problems here. Okay, so 0.417 times 2 times 3.14 times 3 is 7.86 inches. So the distance from here to here on my little circle here on my clock is 7.86 inches. Okay, next question. What is the length of the arc between 3 and 4? Well, if I just want the arc between 3 and 4, I want this section right here. That's just one section. One section out of 12 total sections on the outside of this circle. So length, the arc length is going to be 1/12 times the circumference, or times 2 times pi times r, or times 3. Well, 1/12 is 0.083 times 2 times 3.14 times 3. So 0.083 times 2 times 3.14 times 3 is 1.57 inches. So the distance from here to here is 1.57 inches. Okay, last question here on your guided notes. It says it's 1:35. So let's on my clock, let's write the hands where it would be 1:35. So my hour hand would be about at the 1. And then 35, that's going to be right here on the 7. So what is the length of the arc between the minute and the hour hands? So we want this arc right here. Okay, well that's 1, 2, 3, 4, 5, 6 out of 12 sections. So the arc length is 6/12 times the circumference, or times 2 pi r. Well, 6/12 is 1/2, or 0.5, times 2 times 3.14 times 3. 0.5 times 2 times 3.14 times 3 is 9.42 inches. So halfway around this clock, half of the circumference is going to be 9.42 inches. And I found that by just taking this section the half of the circumference. Okay. So that's the end of the guided notes. That's really the end of this lesson section. Now I'm going to go over a couple of homework problems. So you can follow along with these homework problems with me, get some ahead on your homework, or you can just get started, whichever you prefer. But I'm going to start with homework problem number 8. It says a Ferris wheel has a diameter of 56 feet. So here's this big old Ferris wheel. I don't know exactly where this is. This looks kind of old school. But it says the diameter, oh, that was a really good diameter. The diameter of this Ferris wheel is 56 feet, which would mean that the radius of this Ferris wheel is half of that, or 28 feet. Okay, what are we asked here? It says, how far will an individual travel if the wheel rotates once? So if this wheel rotates one time, how far will someone travel? Well, one time around the outside of this Ferris wheel is the circumference. So I'm just finding the circumference. Circumference is equal to 2 pi r, which is 2 times 3.14 times the radius, which is 28 feet. 2 times 3.14 times 28 is 175.8 feet. About 176 feet is how far you will travel if you go around this Ferris wheel one time. Okay, letter B says, how far will they travel during a 4-minute ride if it rotates once every 20 seconds? So it takes 20 seconds for the Ferris wheel to go around in a full circle, 20 seconds. So let's see. How many 20-second increments are there in a 4-minute ride? Well, 20 seconds, 40 seconds would be 2 rounds. 60 seconds, or a minute, would be 3 rounds. So 3 rounds is 1 minute. Well, I'm on a 4-minute ride, so I'm going 4 times this many rounds. So in 4 minutes, I'm going to go 12 rounds. So I'm going to go 12 times around this Ferris wheel in 4 minutes. Well, how far will I have traveled in 12 rounds? Well, that's just 12 circumferences. So 12 times this distance right here, 175.8 feet. 12 circumferences, or 12 times 175.8, 12 times 175.8 is 2,109.6 feet. Geez, that's like half a mile almost that you'll travel in 4 minutes just going around this Ferris wheel 12 times. Okay, so those are kind of reflections on circumference problems. Now let's look at an arc length problem. This is homework problem number 16. So it says, find the length of each arc to the nearest tenth. So remember, arc length is equal to n over 360 times by the circumference. So I'm taking a fraction of the circle multiplied by the circumference, where n is the angle between the two radiuses in question. Well, the angle in between these two radiuses that I'm talking about is 135 degrees, and the radius, it looks like, is 12. So the arc length is going to be 135 divided by 360 times by 2 times pi times r, or times 12. Well, 135 divided by 360 is 0.375, so I have 0.375 times 2 times 3.14 times 12. So 0.375 times 2 times 3.14 times 12 in my handy-dandy calculator is 28.26, or to the nearest tenth, 28.3. 28.3. So this distance right here is 0.375, or 37% of the whole circumference of the circle, which ends up being about 28.3, whether this is feet or centimeters or whatever they decided to measure it in. And that's it. That's all I've got for you. That's circumference and arc length. So now, hopefully at the end of this video, you feel comfortable finding the circumference of a circle given the radius or the diameter. And then hopefully you're able to find an arc length given an angle in degrees and the radius. Remembering that an arc length is just a fraction of the circumference. So I hope that was helpful. Please reach out to me if you have any questions whatsoever. And I also hope that you enjoyed that as much as I did.